Greetings and salutations, fellow mathletes. Today we are going to be looking at finding the hypotenuse using the Pythagorean theorem. So what I'd like you to remember is that the Pythagorean theorem states that a leg squared plus the leg square equals the hypotenuse square, or we wrote it a squared plus b squared equals c squared. So you will notice I have labeled the missing legs both A and B. So if we go through and we solve this problem, we are going to take 5 squared plus 3 squared equals c squared. 5 squared is 25, 3 squared is 9, and c squared is our unknown. 25 plus 9 is 34. But I'm not interested in what the square coming off of the leg C is, or the hypotenuse C is. I'm interested in what the measure of the hypotenuse is. So we are going to find the square root of c squared, which is just c, and the square root of 34. Now, the square root of 34 is not a perfect square, so we need to use our calculators to find the square root of 34. We know it's going to be between 5 and 6, and when we use our handy-dandy calculators, we see that it is approximately equal to 5 8/10 centimeters. All right, so we look at our next one, and we've got one leg is 8 inches, one leg is 12 inches. So again, following our a squared plus b squared equals c squared, we are going to write our numbers. And 8 squared is 64, 12 squared is 144. So now my task is I add those two numbers up, and I get 208. So now I'm interested in finding what the square root of 208 is. So again, I take out my calculator. I find the square root of 208. I know it's going to be bigger than 14, but less than 15. And it is approximately equal to 14 4/10 inches. All right, pause here and you go ahead and try numbers 3 and 4, and we'll see if we get the same answers. All right, you can go ahead and check your answers. You will notice I'm always using the approximately equal to sign because these are not perfect squares. We are rounding to the nearest tenth, so we want to make sure we use those squiggle for our equals. That's the approximately equal to sign. So number 3, 15 squared plus 6 squared, ends up being c squared is 261, so we find the square root of 261, which is approximately 16 2/10 feet. For number 4, 10 squared plus 7 squared is 149, so our value of c squared is 149. So the square root of 149 is approximately 12 2/10 meters. Our next dilemma becomes, what if we are not directly given information? We aren't told what the legs are or what the hypotenuse is. Well, we've got two different options here. We can use a dot grid or a coordinate grid to find this information. So the question here is, if I were to connect point A and B, you would be asked to find the length of line segment A and B. In order to find that length, I have to make it a right triangle. So I can see that this is my hypotenuse. That is the missing piece. So I count the side here and I get 2. I count the side here and it's 6. So now I know my legs are 2 squared plus 6 squared equals c squared. 2 squared is 4. 6 squared is 36, so my value of c squared is 40. So c squared is 40, so now I need to find the square root of 40. And the square root of 40 is greater than 6, but less than 7, so it is approximately 6 3/10 units. Now again, the question here would be, what is the distance, what is the length of the line between D and C, point C and point D? So again, if I make a right triangle, I can find the solution to this problem. This side is 5, and this side is 6. So my equation is going to be 6 squared plus 5 squared equals C squared. C in this case we could say is line segment CD. That's really what we're interested in. So mathematically, if we're doing some geometry, that's how we would give our answer. All right. So now, got a little quirky pen going on here. 36 plus 25 equals C squared. 36 plus 25 is 61. So we've got 61. So the square root of 61 is C, and we know that the square root of 61, if I use my calculator, is approximately 7 8/10 units. Now, if I'm recording this, I might say line segment CD is approximately 7 8/10 units. The final piece then is if I were given a coordinate grid and either had 2 points already plotted on there or was asked to point 2 plots. In this case, we were asked to plot 2 points, -3, 2, so I go over -3 up 2, and 4, 1. Again, I go over 4 down -1. So ideally, on a grid, we would have been given those points and they would already be there. But again, now my job is to determine what the measure of that line is, or the length of that line. So again, I make it into a right triangle, and I see that I've got 3 squares there and 7 squares here. Now I counted the squares. Technically, I could also look at the fact that I've got these 2 ordered pairs. And I could say the difference between -3 and 4 is 7. So I know one of the legs has a measure of 7, and the difference between 2 and -1 is 3. So again, I'm still using that same information. It's just slightly different methodology to get there. One I'm counting, one I'm actually subtracting within the coordinates. So I've got 3 squared plus 7 squared equals C squared. 3 squared is 9. 7 squared is 49. And that means C squared has a value of 58. So now to solve this, I'm going to find the value of C by finding the square root of 58. When I find the square root of 58, using my calculator, I get that C is approximately 7 6/10 units. Now we are going to operate under the assumption that we always round those non-perfect squares to the 10th digit. So please be very careful about your rounding. You are all capable of rounding. Now we are going to have the opportunity to practice what we have just talked about and work on a worksheet. Thanks for your attention.